Guys, we are starting with the second category of problems of completing squares where the quadratic will have a middle term. So ax square plus bx plus c. So we'll have the middle term over here. Earlier in the previous session, we solved problems wherein middle term was not there. So this time we'll solve problems in which middle term is there. Okay. I'll take a simple problem first. 1 upon x square plus 3x plus 7. Okay. Now guys, we have a middle term. Okay. So whenever there is a middle term, two things you need to remember. Whatever coefficient is there besides x square, it should be 1. If it is not 1, we have to do something else. Okay, that I'll be teaching you. But then if it is 1 or nothing is there, then that's fine. The second thing that we need to do is half into coefficient of x the whole square. So half into 3 the whole square. So 3 by 2 the whole square. Okay. So integration 1 upon x square plus 3x plus 3 by 2 the whole square plus 7 minus 3 by 2 the whole square dx. Okay. So 3 by 2 the whole square, what we are going to do? We are going to place it before the last constant and after the last constant. Okay. Before the last term and after the last term. That is the constant term. Okay. Now closely observe this, the first three terms and the last two terms. Okay. The first three terms and the last two terms. Okay. So the first three terms, it will be x plus 3 by 2 the whole square. So if we combine the first three terms, it will be x plus 3 by 2 the whole square. Okay, so integration 1 upon x plus 3 by 2 the whole square, right? And here simplify this last two terms. So 7 minus 9 by 4. So 7 minus 9 by 4 is 28 minus 9 by 4. Okay, so this will be plus 28 minus 9 by 4. So if you solve this, I hope you're understanding. I'm taking LCM 7 minus 9 by 4, right? So 28 minus 9 by 4. So that is 19 by 4. Okay. So the answer for the last three terms is plus 19 by 4. That plus is also important. So I'll just write plus 19 by 4 dx. Okay. So this can be written as 1 upon x plus 3 by 2 the whole square plus root 19 by 2 the whole square dx. Okay. Express this as a perfect square. Now this inside term is x is x plus 3 by 2, x plus 3 by 2 is a linear algebraic term, not a problem for us. And this is a. So we can compare this with x square plus a square, 1 upon x square plus a square. So 1 upon x square plus a square is 1 upon a tan inverse x by a plus a. So put the value of a. The value of a is root 19 by 2 tan inverse of x plus 3 by 2 root 19 by 2 upon d by dx of x plus 3 by 2 plus c. Okay. Now within the round bracket, tan inverse term, take LCM, and this 2 will go up. Okay. And the denominator answer d by dx of x plus 3 by 2 is 1. Okay. So 2 upon root 19 tan inverse 3x plus 2x plus 3 upon root 19 by 2 upon 2 upon root 19 by 2. Taking LCM within the bracket, 2x plus 3 upon 2 upon root 19 by 2. Okay. So this 2 and 2 will get cancelled after taking LCM, and this is your final answer. So this was the first problem just to demonstrate how to uh, handle the middle term if it's there. Okay. Next problem. Integration of, now let's put a root over here. The basic theme will remain same. x square minus 6x plus, let's say 19. Okay. So we have a middle term. Coefficient of x should be nothing. So uh, it's almost 1. So apart from 1, any other coefficient should not be there whenever there is a middle term. Okay. So write half into coefficient of x the whole square, half into coefficient of x is minus 6. So minus 6 upon 2 is minus 3. But then minus will go because of the square. Minus will go because of the square. So it will be 3 square. Okay, don't open this and write 9. 3 square, keep it as it is only. Okay. So where to place this 3 square? We should place this 3 square before 19. So that is plus 3 square and subtract after 19. So before the last term and after the last term, add and subtract 3 square. Okay. First three terms and the last two terms. First three terms and the last two terms. Okay. So look at the first three terms. X minus 3 the whole square. The combination of the first three terms is x minus 3 the whole square if we combine with the first three terms. So I is equal to 1 upon, don't forget the root. The root is there for the entire problem. X minus 3 the whole square. Okay. Fine. And plus 19 minus 6. 19 minus 6 is plus 13. So I'll just write plus 13 over here. Now 13 is not a perfect square, so we'll express it as a perfect square. So root 13 the whole square. So this is x and this is a. So this is log mod 1 upon root of x square plus a square. So this is log mod. I'll just write down the formula first. X plus root of x square minus a square plus c. X is, if you take a good look, x is x minus 3 and a is root 13. X minus 3 plus root of x minus 3 the whole square plus root 13 the whole square. Okay. Upon dy dx of x minus 3. Now, moreover, what you can do is, which you have to do, this will be 1 and simplify this term within the root. Just simplify this, whatever maximum way you can, possible way you can simplify, just simplify it. Okay. Next variation, next problem. Okay. Integration. Let's take root like this. Root of x square plus x minus 7. Okay. So we have a middle term. So whenever there is a middle term, okay, use half into coefficient of x, but then prior to that, check if any coefficient of x square is there or not. There is no coefficient of x square. Technically, it is 1. That's fine. Any other number is not allowed. Half into coefficient of x the whole square, half into 1 square, which is equal to half square. So integration root x square plus x plus half square minus 7 minus half square. Minus 7 minus half square. Okay. First three terms and the last two terms. So first three terms, see how I'm going to group. X plus 1 by 2 the whole square. So I'll just write it on the next page. This is integration of x plus 1 by 2 the whole square. Okay, and the last two terms. The last two terms are minus 7 minus 1 by 4. So minus 7 minus 1 by 4 is minus 29 by 4. Okay. Now you have to make that 29 by 4 a perfect square. So this equals root of x plus half the whole square minus root 29 by 2 the whole square dx. So this is x and this is a. X and a. Fine. So root of x square minus a square. Root of x square minus a square is log mod. Okay, now this is the bigger formula. Integration of root x square minus a square. So x by 2 root of x square minus a square minus a square by 2 log mod x plus root of x square minus a square plus c. Okay. Now you can put the value of x and a. The value of x is x plus half. Okay. X plus half. That is the value of x in the problem. By comparing, see x is x plus half. X plus half is linear algebraic and a is root 29 by 2. So x plus half the whole square minus root 29 by 2 the whole square minus a. A is root 29 by 2 the whole square. A square upon 2. Okay. So I just write this on the next line. I'm putting the value of x and a in the entire formula. So this term I'm doing now. Minus root 29 by 2 the whole square upon 2. Why upon 2? Because there is upon 2 over here. Log mod x plus half plus root of x plus half the whole square plus root 29 by 2 the whole square plus c. Okay. Now we'll take one term and try to simplify. Look at this term. So this is 2x plus 1 upon 2 the whole upon 2. Okay. So these two terms will get multiplied. Okay. So this will be 2x plus 1 upon 4. The first term will be 2x plus 1 upon 4. Okay. Then this term. So this is 29 by 4 divided by 2. Okay. Root 29 by 2 the whole square is 29 by 4 divided by 2. 4 2s are 8. So this will be 29 by 8. Okay. Now this term within the root is occurring twice. This and this. Okay. So I'm going to simplify this. Okay. X plus 1 by 2 the whole square plus root 29 by 2 the whole square. So x square plus x plus 1 by 4. Okay. A plus b the whole square plus 29 by 4. Okay. I think I missed out on something. It should be x square minus a square. Okay. So this should be also minus over here. So it is minus. Okay. Not plus. It's minus in between. So 1 minus 29 by 4 minus 28 by 4. So this is minus 7. So x square plus x minus 7. So we got the answer for the simplification of this. So this root part, root over here and here we have simplified. Okay. And the last term, that is this. This can be 2x plus 1 upon 2. Okay. So 2x plus 1 upon 4 into root of x square plus x minus 7 minus that green colored term is 29 by 8 log mod 2x plus 1 by 2 plus root of x square plus x minus 7 plus c. Okay. So I hope you understood this problem. This problem will also have dy dx of, in this step, we will have dy dx of x plus 1 upon 2, but then that is 1. Okay. Are you able to understand? Fine. So this is the final answer. Now we'll take another variation of this. 1 upon 4x square plus 3x plus 1 dx. Now I see, listen, we have a middle term over here, but then the problem over here is there is a specific coefficient of x square. So that has to be eliminated first. So we'll eliminate that. 4x square plus 3x by 4 plus 1 by 4. So when you take 4 common, 3 does not have 4. So we have to place that 4 down beneath 3. 1 does not have 4. So we have to place 4 down beneath 1. So this 1 upon 4 we can take outside. And the equation is integration of x square plus 3x by 4 plus 1 by 4. Okay, 3 by 4 plus 1 by 4. Now see, we have a middle term. Coefficient of x square is 1. Middle term is 3x by 4. So half into coefficient of x. Half into coefficient of x the whole square. Half into 3 by 4 the whole square is equal to 3 by 8 the whole square. Okay. So integration, right? 1 by 4, I'll write it as it is. 1 by 4 integration of 1 upon x square plus 3x by 4 plus 3 by 8 the whole square plus 1 by 4 minus 3 by 8 the whole square. So I'm placing this 3 by 8 the whole square. I'm placing this 3 by 8 the whole square before the constant as positive 3 by 8 the whole square and after the constant minus. It is always positive first and then minus. Huh? Yeah. Now the first three terms. First three terms. Okay. X plus 3 by 8. X plus 3 by d whole square. Okay. And the last two terms. 1 by 4 minus 9 by 64. 1 by 4 minus 9 by 64. So into 16 I will do. Okay, so 16 minus 9 is 7 upon 64. So this will be plus 7 upon 64. Okay, plus 7 upon 64. So this equal to 1 by 4. Okay, x plus 3 by d whole square plus root 7 by 80 whole square. Okay, x plus 1 by 4 the whole square plus root 7 by 8d whole square. Okay, x plus 3 by 8d whole square. Sorry, it should be x plus 3 by 8d whole square. Right? X plus 3 by 8d whole square plus root 7 by 8d whole square. Now this is x and this is a. So 1 upon 4 into 1 upon a, 1 upon x square plus a square formula. Now rest of the problem I won't solve. You just have to put the value of x as x plus 3 by 8 and a as root 7 by 8. Apply the appropriate formula and finish off the problem. Fine. And also chain rule will come because in place of x we are having x plus 3 by 8, which is a linear algebraic term. Okay. Let's take one more problem. Integration of root of 2x square plus x minus 1. Now we have a middle term over here. We do have a middle term. But then we have to check what is the coefficient of x square. The coefficient of x square is 2, which has to be eliminated. Whenever the middle term is there, eliminate the coefficient of x square. Okay. Take 2 common. So when we take 2 common, the x term does not have 2. So upon 2 I have written. 1 does not have 2. So upon 2 I have written. Okay. Now you can take this 2 and separate it from the rest of the terms so that root 2 will go outside. And this will be x square plus x by 2 minus 1 by 2 dx. So half into coefficient of x. The coefficient of x is half the whole square. So this is equal to 1 by 4 the whole square. See, the coefficient of x is half over here. Okay. So what you will do is you'll put 1 by 4 the whole square before the constant and minus 1 by 4 the whole square after the constant. So root 2 integration x square plus x by 2 plus 1 by 4 the whole square. Okay, constant is the last term. Last term is minus half. So minus half minus 1 by 4 the whole square. Minus half minus 1 by 4 the whole square dx. Right? So root 2 integration x plus 1 by 4 the whole square minus 1 by 2 minus 1 by 16. Okay, so into 2 I'll do So this is minus 9 by 16. Minus 9 by 16. Okay. After simplification. Okay. Now 9 by 16 you have to express in the form of perfect square. So x plus 1 by 4 the whole square minus 3 by 4 the whole square. So this entire thing is x plus 1 by 4, and this is a. So use 1 upon root of x square minus a square formula. So that formula is x upon 2 root of x square minus a square minus a square by 2 log mod x plus root of x square minus a square. The formula should be very clear. After this, you have to apply the formula, the chain rule, and complete the problem. Okay, simplification till the maximum level. Next problem. Okay, so 1 upon 2 plus 3x minus x square. Okay, now these are different than the previous ones. The initial part is a bit different. So first we always have to rearrange minus x square plus 3x plus 2. So we are not changing the signs. We are just rearranging. Take minus sign common over here. Okay, x square minus 3x minus 2. Okay, now we can take this minus outside also, but then that is not really required. We'll manage that minus sign inside the denominator later on. So keep this minus sign as it is. So half into coefficient of x. So the coefficient of x is minus 3, the whole square. So this is 3 by 2 the whole square. Negative square is positive. So 3 by 2 the whole square. So place 3 by 2 the whole square before the constant and after the constant. Constant is minus 2. So before minus 2 plus 3 by 2 the whole square, after minus 2 minus 3 by 2 the whole square. So this will be I is equal to integration. Don't forget the minus sign which is outside. X square minus 3x plus 3 by 2 the whole square minus 2 minus 3 by 2 the whole square. Okay. Dx. Integration minus of x minus 3 by 2 the whole square, first three terms and the last two terms. Now minus 2 minus 9 by 4. So minus 8 minus 9 by 4, that is minus 17 by 4. Okay, dx. Now we have to manage the minus sign which is outside. So we'll try to work on it. So this is equal to 17 by 4 minus x minus 3 by 2 the whole square. See, minus of a minus b. So this is a, this is b, is equal to b minus a. You can reverse it. Fine. Now 17 by 4, you express it as a perfect square. So integration of 1 upon root 17 by 2 the whole square minus x minus 3 by 2 the whole square. Okay. So this is a and this is x. 1 upon a square minus x square, that is 1 upon 2a log mod a plus x upon a minus x. Now you can put the value of a and x, which I'll show you right now. I'll solve this completely for you to understand. So 1 upon 2a. A is root 17 by 2. If I'm not wrong, it is root 17 by 2. Correct. Log mod and x is x minus 3 by 2. Log mod a plus x upon a minus x upon dy dx of x minus 3 by 2. Okay. X is x minus 3 by 2. Now this part is equal to 1. 2 and 2 is getting cancelled. So 1 upon root 17 log modulus root 17 plus 2x minus 3. Now you have to take LCM over here and here as well. Open the brackets. Root 17 plus 2x minus 3 upon 2. Root 17 plus 2x minus 3 upon 2. and down it will be root 17. Okay, down also take LCM here, minus 2x plus 3, minus minus will become plus after opening the bracket, plus 3 minus 2x plus 3 upon 2. 2 will get cancelled, and this will be the final answer. Fine. I hope you are understanding this. We'll take one more variation of the similar category. Integration of 1 upon root of 3 minus x minus 2x square. Okay. So first rearrange minus 2x square minus x plus 3. Okay. Coefficient of x square is minus 2. So eliminate minus 2. Minus x upon minus 2. 3 upon minus 2. Okay. Now take this, separate this 2 from the root. So this can be written as root 2, but then we can take it outside the integral. Okay, so 1 upon root 2. Minus sign you cannot really take outside the integral. It's a complex number. Okay, so at least separate that 2, but then 2 will go out. This 2 will go out as root 2. So minus bracket x square plus x by 2 minus 3 by 2. X square plus x by 2 minus 3 by 2. So half into coefficient of x. Coefficient of x is half. Okay, which is 1 by 4 the whole square. Don't write it as 1 by 16. 1 by root 2. Okay, so minus x square plus x by 2 plus 1 by 4 the whole square minus 3 by 2 minus 1 by 4 the whole square. So now first three terms and the last two terms. First three terms I have taught you how to take it, x plus 1 by 4 the whole square, and the last two terms minus 3 by 2 minus 1 by 16. So into 8 into 8. So this will be minus 25 by 16. Last two terms. Solve it very clearly, otherwise some silly mistakes might occur. So I is equal to 1 upon root 2 we have taken outside. Okay. 1 upon, take minus sign. So this is x plus 1 by 4 the whole square minus 25 by 16. Okay, now take this minus sign inside, reverse the terms. Just reverse the terms. 25 by 16 minus x plus 1 by 4 the whole square. Okay. So if you solve this further, you'll have to make this perfect square. So I is equal to 1 by root 2 minus, so sorry, not minus, we have done that. 5 by 4 the whole square minus x plus 1 by 4 the whole square. Okay, so this is a and this is x. 1 upon root of a square minus x square. So sine inverse of x by, that is the answer, plus c. So sine inverse of x is x plus 1 by 4, and a is 5 by 4. Right? Upon d by dx of x plus 1 by 4. X plus 1 by 4 is 1. Moreover, what you should do is you should simplify this term which is there inside the round bracket. So this will be 4x plus 1 upon 5. Okay. So this category problems are also completed in which there is a middle term. There is a middle term. Okay. Session 1 was without middle term. That time coefficient of x square didn't matter. Okay. But then whenever there is a middle term, eliminate the coefficient of x square in step number 1. Fine. Okay. Thank you.